All right, guys, going to take just a minute here and talking about where should I take my static pressure readings. I know a lot of people ask me about static pressure. Hey, Gary, where do I take the static pressure reading? Or hey, Gary, where does it need to go? Okay, let's take a real quick look. This is a furnace that I've got here in the training room in Birmingham. So I've got my furnace sitting here, and the way that I look at it, here's the short and the quick of it. What do I check for static pressure? Whatever unit I bought, the fan that the fan comes in, the blower fan, I check on either side of it. So now, this is a furnace. I want to check in my coil. My coil's not bought with my furnace. So I want to check on my coil. And what I have done here, I've got my static probe right in the dead center of my coil here. I've drilled a hole out, a 3/8 hole. I put my static pressure probe, I've pointed it down in the direction in which my airflow will be. And I pulled it through my secondary pan switch. I've taken it out. I've taken my secondary switch out. So what I have it run through, and I've just got a plug with a hole in it. You can actually take this out and keep it with it and do the same thing. My other side is going to be after my filter, but before my unit. So I've got it hooked up. So what I want to do, I can do this. I'll do it today. I'll do it with a dual pressure manometer. We can also do it with our probes. Probes make it really simple, really easy. So let's just go ahead. We'll do it today. We're going to hook up my return to my P2, and I'm going to hook up before my evaporator coil. I'm going to hook up on P1. I'm going to go ahead and I'm going to put this up here on top. Excuse me, I'm going to go ahead and I'm going to run over to my thermostat and I'm going to turn it on, and let's look at our pressures. Okay, she's come on. So I'm looking here and I've got it. I'm going to fail to sit there and turn it on. It is zeroed out. There's nothing running. Okay, she's starting to come up. My fan's come on. Okay, a lot of people will look, if they have a dual port manometer, they will look and say, is this P1 and is this P2? Now this is your differential, but your top number is your P1. So now let's take a look at it. I know it's hard to see, but in the top I have a 0.39 and it's jumping to 0.40. Okay, so that's kind of telling me that maybe one of my vents may be closed off. Let's look at my return. So I'm going to hit P2. My P2 is a 0.05. 0.05. Right? What I'm looking for is a 0.5 static. Something below 0.5 static. I hear people tell me all the time, can it be too low? Not really, unless you go into a negative type number. But it is right now a 0.06. Now, some people will say when they have it in the return, I'm getting a negative number. Do I subtract that? No, you do not. You do not subtract that. You want to just add both numbers no matter what they are. So I'm getting a 0.05. Let's jump back to my P1. I'm getting a 0.41, a little bit of high static. Probably some of these vents have been closed off. Somebody's been maybe testing them, playing with them. I'm getting a 0.4, right now 0.40, and a 0.05. So that lends me to have, on this unit, on this test unit, a 0.45. So I'm still below my where I want to be for a 0.5 static. So on this unit, it would be good. It has the proper airflow. Now, when I said it's a 0.05 and then I look back and I go to my other number and it's jumping between 0.39 and a 0.40, I actually want to get those numbers kind of equal. So I do have a lot of return on this one because we block it off and show how that static pressure increases with dirty filters, with the type of filters and that type of thing. So what I want to do is I will want to balance it as close as possible. When I say balance it, I want the top, if it's a 0.2, I would like the return at a 0.2. Now it's probably never going to be that way, but what I want to do, I want to get it as close as possible. So what I would want to do is to go around, make sure my vents were open, and they're probably, some of them are closed, and I want to make sure everything up top is open so that I can have the best airflow that I can and be as close to each other as possible. So guys, I recommend this if you're going to go out on a unit and let's just say we're going to replace the unit, but the old unit is still running. I've got an old unit out there. I want to go ahead and I want to put this together and I want to check my static pressure. And you say, well, why would you want to do that? Guys, if I'm out there and I'm trying to check static pressure on an old unit, it might tell me, hey, this was designed too small for the unit that was in there. That may be why that unit was trying to go out and use a lot of motors. Hey, yeah, we replaced the motors on this thing 3 times. That may be why that you replace those motors. Take a look at your static pressure. It's very important. I cut a 3/8 inch hole in the return. I cut a 3/8 inch hole up here. You know, you can do that. It doesn't take long, and you can check your static pressure. Guys, you know, we don't want to have to sell the customer, you know, some additional ductwork, but at the same time, guys, you have got to have the proper airflow going through this unit so that you don't have problems, so that you're not replacing motors in this thing, so that you don't go continuously out to this customer and they think, oh man, what a bad unit. When in all actualization, if you would have installed it and done it properly from the start, if it had been done properly, then at that point you may have never seen this customer again unless you're out there cleaning the unit or doing some just some scheduled maintenance. And that's what we really all want. So guys, take a look at your static pressure. We'll take just a minute and we'll take a look at an air handler and what and how we check the static pressure on an air handler. So guys, this is something that you may want to look at when you go to sell or to replace a unit. Make sure you check your static pressures. This is the static pressure. This is how you would do it on a furnace. We'll take a few minutes. I'll be back and we'll look at an air handler. Okay guys, I'm back and I've got this hooked up. Here's what I've done. This is an air handler, and the difference in the air handler is, like I was telling you on the furnace, it's the box that I bought the fan in. As we can see, I've got a clear front here. I got my fan right there. My fan, my coil, and everything else was bought with this box. So my box that includes my fan is the entire thing. So where do I want to check this unit? Well guys, I want to check this unit, and I want to check it in the bottom, coming in after my filter. It comes in from here, and I've got my filter in, so I'm after my filter. And then I want to check it again on the other side of my box. So at the top up here where it goes into my supply, I have another hole cut. Both are 3/8 inch holes. I have inserted my probes. My probes are in there. They're pointed in the direction of the airflow. So I've got it in there. This one is running really super slow because it is an inverter. It is a side discharge. It's an Manometer series. So I'm going to go over here to the thermostat and I'm going to turn it on up to make it run a little faster. So I've went ahead and made a call. I made a call for it to come down at least 4 degrees or more, so it will ramp it on up. Guys, what I want to do here is I want to get it ramped up, and I want to get it up toward full speed. On an inverter, you will want it on full speed so that you can check it. It is starting to ramp up, so I see my pressures here. My P1 is a 0.03, which is super low. My P2 is a 0.01. So I don't even have quite 1 on my static pressure. That is fine on an inverter. But what we want to do, we want to let it ramp on up. And what I'll do is I'll go into the thermostat, and to get this inverter unit, which is a side discharge, whether it be a Goodman, a Manometer, or a Daikin, we want that thing to ramp up. So what we would have to do is to put it into a test mode. So when we put it into our test mode, at that point in time, then we can tell our true static pressure. But for this example, I just wanted to show you that we check it on both sides of the box, because this box includes not only the fan, but it includes our coil as well as our evaporator coil. So we've got it checked on both sides. And that is the way that you will check an air handler. It is very important, guys. It is extremely important that you actually go in there and you actually set this unit up and you check your static pressure. Because if you don't, this unit here, and they are all units, no matter what, getting more and more intelligent. So you want this unit to get in there and you want to be able to handle the pressures. If this unit senses too much static pressure, it will give you a code. It will go out on what they call a B code. So that B is in boy or Bravo. It will go out on that B code, and then after a certain length of time, it will cease to run. So you don't want that. You don't want to have to go back to your customer and say, oh, I'm sorry, you need more supply, or you need more return on your unit. You need this or that. You want to go out and let the customer know, hey, I've looked at all these things. I've looked at everything that needs to be looked at. We are going to need to increase your return, or hey, we may need to add something to your supply. We may need to correct your ductwork. Your ductwork may be old. It may be flex duct. It may have holes in it. You will need to talk to the customer and tell them, say, hey, we need to do some adjustments to your ductwork so that you can properly get all that you can get out of this unit. Static pressure is a big thing in getting it installed correctly. It is important as putting the unit in is to having the correct static pressure. So guys, this is how you will check an air handler.